The Sun, Earth's greatest source of energy. Burning at the heart of our solar system, it's a star that supports almost all life on Earth. It has been worshipped and revered, and now the Marine Corps is making it their newest source of expeditionary power, emboldening their role as America's force in readiness.
The Renewable Sustainable Expeditionary Power Program, RSEP, is a very innovative effort involving a number of technologies, a number of challenges. It's a big step in getting the Marine Corps to their vision of using fuel only for mobility. RSEP is a 5-year ONR Code 30 and Code 33 effort, starting this year with 3 performers, Raytheon, MCOR, and Battelle. A large team working on developing the S&T needed to dramatically reduce fuel consumption on the battlefield.
For Marines, dramatically reducing fuel consumption on the battlefield means a reduction in dependency on fossil fuels, and ultimately a reduction in risk for the men and women supporting forward operating areas.
ONR has worked in the PV area and renewable area quite a bit in the past, most recently on the greens system. RSEP takes us to the next level, so we're going from the greens power level of about 300 watts up to about 3,000 watts.
One of the big things as the Marine Corps goes towards distributed operations and more deployed maneuver of operation, we want our equipment to be as small, as light as possible. So that means either using smaller generators with less electric power or other alternative means of electric power, such as renewable energy sources. So when we look at future systems such as the RSEP, it has to have that capacity to be able to fit onto the light tactical trailer without limiting the mobility performance, but likewise we want to maximize the capability of the system to be able to take maximum advantage of the trailer payload capacity that we have.
ONR is an organization that funds science and technology from basic research through technology readiness level 6, which is basically a prototype in a relevant environment. That's where we focus our resources for both the Navy and Marine Corps needs.
RSEP's approach has 3 prongs. The first is developing and enhancing the science and technology behind converting the sun's energy into electricity using either concentrated photovoltaic or solar thermal. The second is fuel to electric conversion in order to power equipment without the sun's energy. The third prong is the hybridization of those 2 technologies, which represents the greatest challenge to performers on the project. A challenge Battelle Memorial Institute is looking forward to. Their plan involves a concentrated solar thermal approach in which a Stirling engine converts heat into electricity.
When the RSEP BAA came out, we gathered groups from our National Security Division and also from our Energy Division to brainstorm some ideas for the RSEP program. What we came up with was a hybrid dish Stirling system that will operate on concentrated solar heat during the day and JP8 fuel at night.
This is a challenging project. It's the first time that a mobile dish Stirling system has been put together. That brings in a number of interesting innovations on the optical side, on the method of combining the solar heat with the JP8 burner. Battelle's really looking forward to developing a system that can be an efficient, hybrid, transportable system in a cost-effective way.
No stranger to embracing military challenges, Raytheon is employing a similar concentrated solar thermal approach with the Stirling engine.
The Renewable Sustainable Expeditionary Power System looks to push the technology that we developed with the regenerator in order to improve the fuel efficiency of these hybrid tactical power systems. And it does that by using higher efficiency technologies for converting solar energy to electrical power. And it also does it by hybridizing those higher efficiency technologies with fuel burning sources and novel arrangements that are also useful for deployable tactical use by the Marine Corps.
From previous modeling experiences, we've used the IPAM, which is our Intelligent Power Energy Management software suite. Using that, we're able to analyze various inputs such as geographical location. We can do optimization calculations in order to best optimize our hardware and to use it to its fullest extent. We see it more than just saving costs, we're saving lives.
With their solid oxide fuel cell and multi-junction solar cells, EMCOR Corporation's approach differs from that of Battelle and Raytheon.
So what we've been looking at is the opportunity to use the high efficiency that you can get from concentrating photovoltaic systems to reduce the area that's required to supply enough power for expeditionary forces. What we've been doing for this program is looking at an optimization of the system that we've developed here to be compatible with the transportation requirements for the ONR RCEP program. With the solid oxide fuel cell as well as the CPV, we're able to meet or exceed the targets of 40% fuel reduction for the system.
Traditionally, this technology has been deployed in utility scale systems. What we're proposing with RCEP is slight modifications to the basic technology, and it will be used for deploying it on trailers for the Marines that they will deploy in forward operating bases. Our concentrating photovoltaic system will be used in conjunction with solid oxide fuel cell and batteries to provide power continuously when the sun is not out.
So there are three complementary approaches taking different paths, and we're quite happy about that. And we're looking forward to seeing which of the technologies performs better in which environments, what are the cost profiles, and how each meets the Marine Corps need in the best fashion. The RCEP program is all about ideas, all about innovation for the warfighter. It's a very exciting effort. How far can we go with fuel consumption reduction? How easy can we make this system for the Marine Corps to operate? How reliable will it be? What's the life of this system? There's a lot to learn over the next 4 years, and I really look forward to working with the performers and the overall team.